Hello everyone, myself Ms. Shailaja Doddi, Assistant Professor, Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's lecture, we are going to study composition of the forces. In this lecture, we are going to study how to calculate the resultant of coplanar non-concurrent force system. At the end of this lecture, the students will able to define the various types of system of forces, how to apply the conditions of equilibrium to the given force system, and to determine the resultant of coplanar non-concurrent force system. So these are the various system of forces. Collinear force system. In this, the line of action of all the forces is same along the line. Second one is coplanar parallel forces. So these are the forces which are parallel to each other, but there may be the direction is different, and these all forces will lie in a single plane. The next one is coplanar like parallel forces. In this force system, all the forces are parallel to each other and the direction of the forces is same, and these are lies in the single plane. Then coplanar concurrent forces. These are the forces which meet at a single point and these lies in a single plane. Then coplanar non-concurrent force system. So these are the forces which are lies in a single plane but which will not meet at a single point. Non-coplanar parallel forces. These are the forces which are parallel to each other but they are in different planes. Then non-coplanar non-concurrent forces. So these are the forces which will not meet at a single point and all the forces are in a different plane. So these are, as I told in this lecture, we will study how to find the resultant force of non-concurrent force system. So here it is coplanar non-concurrent force system. So all the forces which lie in a single plane but do not pass through a single point are known as coplanar non-concurrent force system. Here it is the general method to find out the resultant of the given force system. So in this system, the forces F1, F2, F3 and F4 are acting in a different quadrant. So we have to calculate the resultant of all these forces. What is meant by resultant force? It is a single force which will give the same effect that of the forces acting on the body. So to find out the resultant force, we have to calculate the horizontal components of all these forces and the vertical components. If you see, all the forces are inclined. Okay, so we cannot consider directly these inclined forces. So for that we have to first calculate the components of each forces. So the process of finding out the resultant force is nothing but the composition of forces. Okay. So as I told, first of all we have to find out the horizontal and vertical components of the all forces in x and y direction. Afterwards we have to consider the sum of horizontal components and the sum of vertical components. And it will be kept in this formula, that is resultant R is equal to under root summation of fx square plus summation of fy square. So it is nothing but the magnitude of the resultant. Then the direction of the resultant is given by alpha is equal to tan inverse of summation f of y and summation f of x. Now we will see how to calculate the resultant force of this given non-concurrent force system. So in this question they have mentioned the dimensions of this each square is of 10 mm. Okay, so first force is acting at this point A, so it is acting like this. It is of 2 kilonewton. And the second force is acting from this point. It is of 5 kilonewton, and this is point B, I will say, and or here we can see it is point B. Okay, and the third force is acting at point C, which is of 15 kilonewton. Okay, so first of all we have to find out the inclination of all these forces. So here for force F1 it is theta 1, and force F2 here it is theta 2, and force F3 here it is theta 3. This force will coincides with this coordinate like this. Okay, so this will be the theta 2. Now how to find out this theta 1, theta 2 and theta 3? Here we have to consider the trigonometries. So here I will consider tan inverse of, or tan theta is equal to y by x. So here it is tan inverse of y by x. So here you will get what is the y distance if I consider this triangle. Okay, so I will draw here. The force is acting like this. So it is 1 square, it is of 10 mm. Okay, here it is also of 10 mm dimension. Okay, so here it will be tan inverse of 10 by 10. So here you will get the theta 1 is equal to 45 degree. Then theta 2. So if I consider the theta 2, tan inverse of y by x, here we will get the vertical dimensions, that is 1 square, 2 and 3. Okay, and the horizontal direction 1, 2, 3 and this last one 4. So it is tan inverse of 3 by 4 or 30 by 40. So here you will get theta 2 is equal to 36.87 degree. Then theta 3. So if you consider the vertical dimension it is 10 and the horizontal dimension it is 10 plus 10. So this will be the triangle for the theta 3. So it is tan inverse of y by x. So here you will get tan inverse of 10 by 20. So how much is theta 3? It is 26.56 degree. Okay, afterwards we have to calculate the components of each and every forces. So here this 2 kilonewton force is acting in upward direction. The component will be like this. It is horizontal component and here it will be vertical component. Okay. So I will first consider the conditions of the equilibrium, that is summation f of x is equal to 0 and the summation f of y is equal to 0. So first one is summation f of x is equal to 0. So we have to consider the component of all horizontal forces. So the component of this 5 kilonewton forces are like this, and for the third force, that is 15 kilonewton, these are like this. Okay, so first according to the direction, the horizontal component of 2 kilonewton force is positive. So it is 2 cos theta plus, again this 5 kilonewton is also acting towards the right side, it is again positive, cos theta 1, here theta 2. Then this 15 kilonewton force horizontal component, it is acting towards the left. So here it is negative. So it is minus 15 cos theta 3. So here you will get 2 cos 45 plus 5 cos 36.87 minus 15 cos 26.56. So finally the summation f of x is equal to, it is 4.072 kilonewton. Accordingly we have to calculate summation f of y. So summation f of y is equal to 0, which will be the equilibrium condition. So if you see here, only the vertical component of this 2 kilonewton force is acting vertically upward, so it will be positive, and remaining two components for 5 kilonewton and 15 kilonewton, those are acting downward direction. Okay, so these will be negative. So here it is 2 sin theta 1 minus 5 sin theta 2 minus 15 sin theta 3. So here you will get 2 sin 45 minus 5 sin 36.87 minus 15 sin 26.56. So summation of f of y will be minus 2.257 kilo Newton. Okay. Now we have to put these values in equation of resultant, that is R is equal to under root summation fx square plus summation fy square. So here you will get 4.072 square plus 2.25 minus 2.257 square. So resultant will be 4.655 kilo Newton. Okay, and then the direction of the resultant, which is nothing but alpha is equal to tan inverse of summation f of y by summation f of x. So here it is tan inverse of summation f of y is 2.257. Here it is negative value, but we will not consider because this negative value will indicate in which quadrant the resultant will lies. Okay, so here it is 2.257 divided by 4.072. So you will get alpha is equal to this 29 degree. Okay, so likewise you have to calculate the resultant magnitude and direction of the resultant for the given non-concurrent force system. Okay, so here you can show the position of the resultant like this. It is x-x axis, it is y-y axis. Okay, so first of all you have to find out the x and y quadrant, x and y coordinates, and accordingly you have to show. So this minus y, here summation f of y is minus. So if we see the quadrant notification, here first quadrant plus plus, second quadrant minus plus, third quadrant is minus minus, fourth one is minus plus minus. Okay, so here summation f of x is positive and summation f of y is negative. So what it will indicate? This resultant will lie in the fourth quadrant. So likewise you have to show the position of the resultant force. Okay, so it is the question given for the assignment. Solve it, take some time and try to solve it. So these are the answers, means resultant of this particular force system is 91.819 kilonewton and the direction is 35.83 degree. These are the references used for the further study. Thank you.